Yes, good evening, guys. Good evening. Can you hear me? Yes, good evening. Can you hear me? Good evening. Am I audible?
Yes.
Oh, thank you there. So, yes, welcome back again to our AI engineering intermediates. And so far, so good. We are proceeding with advanced Python concepts, where yesterday we introduced data structures and we also mentioned object-oriented programming. So today we want to proceed with those advanced concepts where we are going to proceed with OOP. Then now we touch on decorators. Just like I had mentioned this week, we will be doing this advanced Python concept. Comfortable to work with Python from basics to production ready programs. So before we proceed, I want to share with you the notebook on the chart that we will be using for our today's session. And what I've come to realize that these concepts are very advanced. So I'll only be taking 1 hour, then giving you something to go and research. So allow me to share the notebook that we'll be using on the chart. So kindly check the chart where I've shared the link to Google Colab notebook that we're going to use for this class. Yes, I hope you're together up to there. Yes, so yesterday we introduced Python advanced concepts. And for this week, we are going to tackle very advanced topics in Python, which we say there are only 5. Not only 5, but I think 5 are the most fundamental ones. And they are listed. One that we started with yesterday was really to think about data structure. Like I mentioned yesterday, it focuses efficiently so that now people can access, can search those data efficiently. So if you're talking about efficiency, we measure them in terms of time complexity and space complexity. Okay, time complexity, like we said yesterday, it's how long will the program take to execute an operation. On the other hand, space complexity thinks about how the memory that the program would use as it is executing different tasks. So because data structures and algorithms are very wide and broad topic, I just wanted to compare between two data structure, a list and a set, just like we saw yesterday. There is a use case where you can work with the list, and there is another use case where you can work with a set. We mentioned other ones like tuples, dictionaries, and then I wanted you to research more on linked lists, stacks, and queues. So if you want to really now practice your data structure knowledge, we most of the time I highly recommend this website called LeetCode. This website called LeetCode is a very popular website where you can now practice your Python skills because most companies, their interviews focuses on LeetCode. So this is actually one area where you can create an account and practice your Python knowledge. So I'm going to leave this one for you as you now research more on data structures. So I'm sharing the link on the chat, LeetCode. So that is something we mentioned yesterday. At least now we have an idea of what is data structures and why data structures is very helpful in advanced Python applications. So the second module that our advanced Python concept was supposed to cover was object-oriented programming. So I think that is what I will be proceeding with today. Object-oriented programming. The third one that we should tackle is the idea of decorators, something we want to introduce today as well. So where is it? Decorators. Then apart from decorators, you also have generators. They're here. Generators. And then finally we have Pydantic Python for data, for data validation. So allow me to proceed with object-oriented programming because it's the one that we're going to use a lot during our intermediate level AI applications. So yesterday we introduced object-oriented programming. I think we also had some very good definition from some of the students. Yes, this one here, object-oriented programming. So if you are not there, just a quick recap, we had said that object-oriented programming is a programming style or a programming paradigm that focuses on using objects to tackle different tasks within a program. So the big idea about object-oriented programming is objects. So that's why we said that now for us to really understand OOP, then we need to know what is an object. And clearly we saw that an object is anything that has attributes and behaviors. In other words, attributes, we said they are called states, behaviors, they are called actions, okay? So anything that you can think of that have attributes and behavior, it's called an object. For example, if you think about your phone is an object because it has attributes like memory, size, SIM, color, in such a way that an object tries to reflect, the attributes tries to reflect what an object has, okay? Then with the phone, you can do some actions like you can call, you can chat, you can do selfie. So those are the actions that we call behaviors, or we can also call them methods. They are actions that can be performed by these objects. Similarly to a person, car. We needed to know now what is a class. And we saw that a class is a blueprint or the design that is used to build object. Therefore, inside a class, we define states and behaviors of these objects that we are going to create, okay? So we gave a very, very good example of a car. So let's say you want to model a car within your code. So the car would have some states and also some behaviors in such a way that a state of a car refers to the attributes that every car has. So every car has attributes like the make, the model, year, color, price. And for every car, people can drive, you can park, and so on and so forth. So, and we saw that out of this blueprint, we can now create instances of the class. So if you're creating an instance of a class, that is what we call an object. First instance of our car blueprint. Another one is Ford. So in other words, an object is also an instance of a class. So we also gave a good example of OOP in such a way that we have something like a cookie cutter. So every cookie cutter will actually provide the shape of your cookie. And therefore, the actions you can do with the cookie cutter is to cut the cookies. So this is also a blueprint to define different cookie cutters. So we have a cookie cutter that can make star shape, another one can make heart, another one can make square. Now we did more realistic examples. We did a realistic example, a real world example of where we can apply object-oriented programming. And a good example we saw was in banking. Because now with a bank, we first need to state the attributes that we need for every bank account in such a way that every bank account has an owner and the initial balance. And then now the method refers to what you can do with your account. So for instance, with your account, you can do some deposits, which is now an action or a behavior. You can check your balance. So every account that you create from this blueprint, it's an instance. So it's an object. So this is an object that was designed by this class called bank account. And as you're creating that object, you define now its specific attributes and method. Okay? You define its specific attributes and method. So these are now the instances of the bank account class. And you saw that this is very, very useful because now from one design, we are now able to generate several bank of our bank account classes. So I think that is what we did yesterday. So today I just wanted to show you more practical examples of object-oriented programming. And then now we introduce decorators and then we call it a day. So for today, I have different examples. I wanted us to think about OOP as everything that we know. For example, your mobile wallet. If you are working with like something like PayPal, your mobile wallet. So every mobile wallet should have an owner, or let's say you're talking about Binance. So your mobile wallet, you should define the owner of that mobile wallet. And then you should also define the balance within that mobile wallet. So these are the states. Something that you should always remember is that anytime you define the states, you should call it inside the init method, init function. Yeah, init function. So that now this self argument will pass these values as now the attributes of that class. I hope you get it now, okay? And then now with your mobile wallet, I hope you're seeing that one. With your mobile wallet, there are things you can do within your mobile wallets that we call actions or behaviors. For example, with your mobile wallet, you can add some money to your mobile wallet because this is a function within a class. It must have the self argument. It's not just any other function. It is a function that is being used within a class. So every time you have a function within a class, it should always provide the self argument, okay? Then now, as you're using this function, for you to add some money to your mobile wallet, you need the amount. So we are going to take your initial balance that we had within the class. Remember, we can access values within that class using the self argument. It's very, very important. And then we add the amount. We add the amount. And then now we return the information within your account. Like we can return the owner added the following amount, and then your balance is this one. Same time within your mobile wallet, you can spend some cash. And then if you want to spend some cash, you need to define the amount that you're spending. And this amount that you're spending, we can even do a conditional check that if that amount that you're spending should not exceed your balance. So remember, with the self.balance argument, we are able to access your initial balance within the account. So if it's more than that, then you don't have enough balance within your mobile wallet. If that is not the case, then we can now deduct from the balance. We can now deduct the amount and then return the information. So, for example, this was a good example. I have created the first wallet. Maybe I'm building something like Binance. My mobile wallet, I am the owner, and then my balance is 1,000 shilling. Another wallet we have is for Alice, and the balance is 500. So if the first wallet, which belongs to Eric, I decide to add more cash, like I add 300, I hope you're getting that now my balance, Eric added 300 shilling, this one, to, now my balance is 1,000. What about Alice? If Alice was having initial balance of 500 and Alice decides to spend 200 shillings, then the remaining balance is 300. So this code clearly tries to show us that with object-oriented programming, we can think of mobile wallet accounts as objects in such a way that now we are able to build the blueprint of how each mobile wallet account would look like. And then from there, using this blueprint, we are able to now build several mobile wallets. Any question up to there? So I wanted you to try out this one. Maybe, I don't know which other functionality you can do with the mobile wallet. Which other functionality can you do with the mobile wallet? So which other functionality we can do with the mobile wallet? I think we can check balance, but I think that is very, very easy. So if you're checking the balance, you're just returning the self.balance. I think we can try it here. Another functionality we can do here is we can define a function to check balance. Okay, to check balance. So because every time you have a mobile wallet account, you normally want to check your balance. So we have a function for that one. And then we can return the owner of that account and their balances. I hope you've seen how object-oriented programming makes now to build AI application using object-oriented programming. We are going now to reduce the complexities within those applications. Yeah, so if I decide to check my balance, so I can print here. Let me print. And I think we had already done that one. Maybe wallet one, we check your balance. Sorry. So if you don't have this notebook, I can share it on the chat. Please keep on following the notebook. Like that one. So let me see what we get. Now we get that Eric current balance is 300. So you're able to check your balance. And it has a memory to remember that you had a balance of 1,300. So if you don't have the notebook, kindly let me know. I can share it again on the chat so that now everyone can follow it together. And if you have any question or any clarification, please always feel free to pass the clarifications on the chat. Yeah, someone else is having another complex application, like you want to build student information system. So if you're building a student information system, we can think of students as objects in such a way that for every student, there should be attributes like the student name and the student admission number. So that student, it's an object, okay? And then constant values can be passed here, like marks. So these are values that you don't want to pass as constructors here. So you can always pass them inside the function, and then we can work with them there. So for every student, we can have their names and their admission numbers, and then we can now calculate their marks. So remember, students cannot pass their marks here. You cannot pass your own marks here. We need to calculate your marks. That's why the variable marks, is being passed inside the class. So this is a student object, and for every student, we need to know their name, their admission number, and then we're able to calculate their marks, but we cannot pass them here. So the first function that we can have for every student is to add the marks. So if I want to add your marks, you need to provide with me your marks. Then I'm going to increment the original marks that was 0. So remember, for every student, as we are initializing your information, we now make your marks to 0. So if you add any marks, we are going to increment this one to the marks that you've added here, okay? And then if you want to get the result, so we are going to say this that we've added. I hope you can see that one. Yeah, so for example, we have a student like Brian with this admission number. So remember, these were values, these were parameters that we were expected to pass here, so that we can now pass them as attributes. So the first instance of our student is Brian, and Brian's admission number is this one here. Another instance of student is Mary, and the admission number for Mary is here. So for every student, I hope you can see there, we can take the first student, we add the mark 78. The other student, we take the marks, we add 85. And then now we can print to get their result. And I hope you're seeing that Brian scored 78 marks, because remember, for Brian's instance, we added 78. Remember, Brian was the first student, student 1. So we added 78. For the second student, we added 85. And now we are getting their marks being returned here. So I hope you're, with those many examples that I'm trying to use, I hope now you're getting the idea of object-oriented programming. So to repeat it, we are now thinking of everything as objects in such a way that every object must have, they must have states or attributes and behaviors here. So I even have more examples. I don't know whether I'd have time to go through all of them. For example, if you go to any e-commerce platform, there is a shopping cart. I don't know whether yes, every e-commerce platform we have a shopping cart. So that shopping cart is an object, because we can think about the owner of that shopping cart and the total amount that was spent by that owner. So for every owner, you can add an item based on the prices, and then you can go ahead and make some payment. You can go and do some checkout. You are now making payments. I don't know whether I'm making sense there. So if I open a website like Jumia, this website has a shopping cart here. I hope you can see it here. So is it still loading? Yes, it has opened. So this is the shopping cart. So with the shopping cart, there is a function to add. This is what we are trying to simulate here. We can add an item to a shopping cart based on the price. So as you add an item to a shopping cart, we check the price. I hope you're getting that one. So if I add this item to the cart, this Amtech 32-inch smart TV, if I add it to my cart, this one, we are going to take into account the cost. I hope you can see here. We need to take into account the cost. And then if you want to do some checkout, we need to know the total. For example, I can even buy this third one, like that one. So at least I have two items within my shopping cart, that one. So now, if you want to do the checkout, we need to get the total for every item within your shopping cart. So that is a classical example of where you can now apply object-oriented programming, okay? So for example, Magdalene wants to have a shopping cart. So Magdalene, you've added an item of 500 shilling, another item of 300 shilling. So if you want to do your checkout, your total payment should be now 800. So that is object-oriented programming. And so many other ones, like your phone contact is an object. Yes. So any question up to there? With OOP, anyone now with a question? With object-oriented programming. Anyone with a question? Now, what makes object-oriented programming special? It is some 4 concepts that it has. So object-oriented programming have 4 major concepts that I wanted each and every one of us to try and research. And then you can paste your research results on the chat so that now we can go through them. So if you want to really advance on object-oriented programming, and provided you've understood what is a class and what are objects, then object-oriented programming have 4 major concepts that I think we cannot cover in this class, but we can just mention them. So the first concept we have is something we call inheritance that I wanted to demonstrate here today. Then over your free time, because this class will be more of research-based, you can research more about what is encapsulation, what do you mean by polymorphism, and what is abstraction. And these 4 concepts are actually now makes object-oriented programming special. So anyone to volunteer and research for us what is inheritance in object-oriented programming? So anyone to volunteer? Yes, so I think Magdalene, you've researched for the first one. Yeah, so if you're researching on encapsulation in object-oriented programming, it means that we're able to bind data and method together and restrict access to data. So if you're talking about encapsulation, just like you're seeing the definition, it focuses on data security. Yeah, so you're going full, especially if you're now working with complex applications. So encapsulation will ensure that we restrict access to data. We are ensuring that we have data security and data integrity. Yes, on the other hand, yes, inheritance, I hope you can see on the chart, you can check on the chart. Inheritance allows class, so I think I can write this one here. So inheritance allows Yes, there's even more explanation with Michael's explanation, so we're going to go through that one. So it allows a class to reuse another class properties and methods. Properties and method. That is very, very true there. Thank you. So if you try to compare that one with what Michael has presented, we are being told that inheritance is a mechanism we find in OOP, whereby we allow a new class that we are going to call a child class to acquire properties and behaviors of another class. So it's like one class is able to inherit properties and behaviors of another class. So I think this one we had said it kind of restrict access to data, therefore providing what we call data security. Yes. So I hope you're getting how this one is becoming even more interesting as you now dive deeper into that one. Now, in terms of polymorphism, just like the name suggests, poly. So I think poly means many. Poly means many. Poly means many in such a way that the same method behaves differently. Yes. I think let me show you how polymorphism is achieved here. Same method name behave differently. Yes, that is very, very true. I'm saying behave differently. So how should we think about polymorphism? Let me show you a good example here. There is this function called show contact. I hope you have seen that function. I don't know whether yes, we are getting so many good explanation here. So if you're talking about polymorphism, a method, so remember a method is, we also called it a behavior. So a behavior. Behave differently with different instances in such a way that, let me show you this one here. The first instance of show contact is giving us the phone contact. Another example that we use, I think that should be it. Now, the same method, if we try it with another